Hello everyone, and welcome to Grid Gain Systems webinar, Scalable Full-Text Search with Apache Ignite. I'm Nicole van Geleur and will be today's moderator. Before starting, I will need to conduct a little housekeeping. Can you raise your hand with hand icon on the left of your screen if you can hear me? Can you use the hand icon and see if you can hear me? I don't see a show of hands. I'm going to assume that the attendees can hear me at this point. On behalf of today's webinar presenter, thanks for joining us. I'd like to introduce our speaker for today. Courtney Robinson is CTO of Hippie, and he has a focus on Ignite. He will talk about Hippie's use of Apache Ignite today. If at any point during the webinar you have a question, please type it in the Q&A panel. Questions will be addressed at the end of the webinar. Please also note that your phones will be muted throughout the presentation. You've joined us today to hear about Scalable full-text search with Apache Ignite. At the end of the webinar, we'll close out by taking your questions. With that, I'd like to now turn things over to our expert, Courtney Robinson.
Thank you, Nicole. So welcome everyone, and I'm going to talk to you today about what Hippie is and how we use Apache Ignite to enable our customers to build their applications. So as Nicole pointed out, I am the founder and CTO at Hippie, and Hippie is effectively a rapid application development platform. And what we're looking to do and what we've helped our customers to do is to reduce the time and cost it takes for them to build applications. So in some cases, we've been able to reduce the time a company takes to build their application from several months to several weeks. And I'm going to talk to you today a little bit about how we do that and then how that links in with Apache Ignite. So Hippie provides a developer platform, and it's something that as a developer you would you download and you can run it on premise, or as we're about to do in the next 2 months, we will have a cloud hosted version as well. And typically what you would do is you would write a model of what you're looking to build, so a data model, and from that data model, Hippie will then generate a CRUD API and allows you to execute serverless functions so that you can extend the generated API. Now, the model that I mentioned earlier is written in GraphQL, and GraphQL is a technology that was open sourced by Facebook a few years ago. It started out as being just a query language, but is evolving. And one of the things that has been added to it is the schema definition language. And when you work with Hippie, it's the schema definition language that you use to define your data models. So GraphQL as a query language, it's very expressive. It's very succinct. One of the things that Facebook sold it on when it was first open source was that they were using it in their mobile app. When you're looking to get data in or out, you can choose exactly which fields to query for on a per query basis. And it's relatively flexible. So if, for example, Hippie provides you with some default functionality and you would like in your app to then extend that or completely change the semantics of it, you're allowed to do that. And you can do that through the use of what GraphQL called directives. So in this webinar, we're going to build a quick to-do app just to demonstrate how you would use this. And I will focus more on the querying aspect, as obviously the webinar is supposed to be talking about full text search. So I'll focus more on the querying aspect of the app, but we will put together an entire working app within the webinar, and it will only take a few minutes to do that. Now, we'll limit the scope of this to just being able to create to-do items, being able to add comments to them, and then focusing on being able to search for the items that we've added. So on screen is the data model that we're going to be working with. And on the right, that's the schema definition language that GraphQL allows you to write. So the very first model in that is the item type. And that definition is basically saying that an item has 6 fields: slug, summary, started, a due date, attachments, and comments. Now, an important thing to notice about the definition is that they're not using IDs that you then have to query later. It's using the actual type that you're referencing. So in the case of comments, the field is an array of comments, and that the square bracket is GraphQL's syntax for defining an array of some type, and the same goes for attachments. Now, I mentioned earlier that you can extend behavior that we provide, but one of the built-in extensions that we have, this isn't something that comes with GraphQL, one of the built-in extensions that we have is the ability for you to index any field in your data model. And that's what we'll be looking at today. So the at field syntax on those fields that you can see is a GraphQL directive. Now, the first parameter, indexed, that just tells Hippie that you would like to have this field indexed, and you can index a field in multiple ways. So one of them is what's called a keyword indexing. So if you're familiar with technologies like Elasticsearch or Solr, then when you index something using a keyword, then it will match that field exactly, which is something that's typically used for IDs and other fields that you might need to match on exactly. If you don't provide the type that you're looking to index a field by, then it assumes basically what's called a phrase query. So if you're familiar with Elasticsearch again or Lucene, then it will index that field so that you can search on it in the same way that you might search using a search engine. So it's a very simple model, and this is the one that we'll be demoing shortly. So you have an item type, you have an attachment type, you have a comment type. Now, there are a couple of points here. When you provide this model to Hippie, what we will do on the fly, if you're familiar with Ignite, or rather, if you're not familiar with Ignite, Ignite works based on the concept of caches. And what Hippie does is every data model will get mapped to a cache in Ignite. You can imagine a cache as being similar to, in concept, to a table from a relational database. So Hippie will map each of your models to an Ignite cache. And it will also generate an associated Lucene index. And we're using something that I'll go on to in more detail later. Again, another technology from Facebook that was actually based on Google's LevelDB, RocksDB. So RocksDB is a key value store, and I'll mention later what we're using that for and how. Lucene is being used for the full text searching that we'll be covering today. And by default, Ignite actually has Lucene as a dependency on the class bar. So actually all we've done is extended the functionality that it already has. If you're using Ignite's SQL API, and Ignite allows you to use lots of different APIs to get data in and out. If you're using the SQL APIs, then it allows you to index fields using Lucene, but the scope of what you can do with it is fairly limited. So what we'll go through today is how we've more or less extended that and exposed the full capacity of what Lucene is capable of doing. The other thing to mention on this slide is that from the model that I showed you earlier, there were no direct references to foreign keys, etc. Hippie, when you write your model, will automatically generate those for you. And I'll explain a bit about how that happens when we get onto the next slide. Now, I mentioned that Hippie gives you a CRUD API. It's kind of CRUD with trash, because we have the concept of being able to trash an item, which will prevent it from being returned in results unless you explicitly ask for it, that you can then permanently delete later. But the core API for performing CRUD operations is displayed on screen. So you will get a function, a GraphQL function, to be able to find an item, and there is a function per GraphQL type in your model. So here I've just written out an example of the API that you would get to be able to work with items. So you'd get a find item, a create item, update, and a delete item. Now, the important parameter that we'll be focusing on is the arcql parameter, and that is effectively a DSL that allows you to write queries that will be executed against the Lucene indexes that we're generating in Apache Ignite. So arcql, simple DSL, relatively simple. It has, and we've deliberately tried to make it have an SQL-like feel to it. In Apache Lucene, there are about 7 kind of core types of queries that you can perform. And the syntax of arcql is broken up into 4 pieces. The first part is the query, and that allows you to specify the thing that you're looking for. And then you can choose to sort by some field, and you can do like a dot notation. So if you have nested fields, so if you wanted to search by comments.text, sort that by comments.text, then you could do comments.text, and you can optionally choose to have ascending or descending order on it. There's also a from parameter in the query, and every Hippie query allows you to get a pagination token that you can then use in your subsequent queries to be able to paginate through results. And the last piece of it is a limit, which is simply a limit keyword followed by some number that you would like to restrict the return results to. The 7 types of queries, in all cases, the syntax is pretty much the same. You have some field name followed by an operator, followed by quotes and the thing that you're searching for. Term queries, I mentioned earlier, is where you're looking to do an exact match on a field. So that's good for things like IDs. Phrase queries are good for being able to search for things like you would do in a search engine. Then prefix queries would match terms at the start of the word. And wildcard allows you to search. There are 2 types. So there's one that will match a single character, and that's what the question mark is for in that syntax. And then the other type is what you might be more familiar with, the asterisks, and that will just match any character from that point onwards. Then there's fuzzy matching, and that allows you to do effectively match transpositions of words. So name, same, etc. would match that query that's on screen. And then you have range queries, and your range queries allow you to find values that are within some specific range, and the syntax is what you would expect from a mathematical range. So you can do square brackets on either side or parentheses on either side to specify upper and lower. And then the last type of query that you can do is a match all, and the match all is just an asterisk, and that will just return any results that match your type, and you can still then do pagination and limits, etc. on it. So how do we go about implementing all of this? Like I mentioned earlier, each GraphQL type that you define gets a Lucene index, a Lucene cache generated for it. So the first thing that happens is Hippie will take your GraphQL query and it will generate an algebraic representation of your query. From that structure, it then has operations that the whole tree is closed over, and we then map those onto various parts of the Ignite API. Now, Ignite cache APIs, I mentioned earlier that there are a few of them. The one that we use consistently is the key value API. The key value API, we will take your query. So if it's a simple RQL query, like just finding something by an ID, then we'll take that query. That goes through what Ignite calls an affinity function, and an affinity function allows you to effectively choose which nodes you would like to have data associated with. And what we've done is we've taken that slightly further, because we not only do associations to nodes on data when it's being stored, but we also do it based on a number of criteria that you can specify. So you can use affinities to effectively choose, let's say some servers had SSDs, some servers had GPUs. You can use the affinity functions to be able to associate data with specific nodes that match those filter criteria. And then the last thing inside that is Ignite allows you to specify your own cache store. Now, Ignite is a memory-centric platform, so by default, unless you've configured some kind of persistent storage, your data will all be cached in memory, distributed across your cluster, and it will be as fast as it can get. Everything will be in memory. But obviously, then if you lose your entire cluster for some reason, all your data was in memory, so it all goes. Hippie by default persists everything, and we do that using our own cache store, and that cache store is implemented on top of RocksDB. And Ignite has a built-in persistent storage, and we opted not to use that. Now, what will happen is the cache store will actually decide where to put your data when you're performing operations. So if you were to create a new record, then it would write some to, for example, Lucene, and then write it to RocksDB simultaneously. I mentioned earlier about how the affinity function is available and allows you to send data to different locations. It does a fair amount more than that. It uses a hashing algorithm called rendezvous hashing. If you're familiar with Cassandra or other technologies like it, then they typically use consistent hashing. Rendezvous hashing is an alternative to that. And we chose to do that because in consistent hashing, you can sometimes end up with hotspots, and then you have to start doing things like introducing virtual nodes, etc. With rendezvous hashing, you reduce the chances of those hotspots happening without having to do any additional work like virtual nodes, etc. And the other thing I mentioned was that you can specify node requirements. So if you wanted to write data and have that data only persist to nodes that had SSDs or nodes that had GPUs available, then you would configure your servers and specify what node requirements they fulfill. Then your queries, when you execute them, would only get your data queried or stored on the nodes that match those requirements. Now, Lucene and RocksDB are two very different technologies. So when we map your data during a put or a get, we have to choose effectively at what point do we go to Lucene, and then once we've had the results from Lucene, how do we then go to RocksDB? So as a query to get data out actually hits both storage technologies if we have to go to disk for it. Ignite has, as I mentioned earlier, is memory centric. So by default, it actually caches a lot of stuff in memory for you. So it's not always the case that we will go to disk, but if the data isn't already in the in-memory caches, then we would go to disk. And when we do go to disk, that does mean that we are querying twice effectively, because we have to first go to Lucene and to RocksDB. But in general, we found that that's not that much of an issue. The benchmarks that we've done so far, we average around 10 milliseconds for hitting both Lucene and RocksDB on relatively large clusters. So one of the things that when we present this and we talk to people about it, there are some obvious questions that come up. Why didn't we use Solr? Why didn't we use Elasticsearch, etc.? Now, using those technologies is great off the shelf, but Ignite, there's no need to do it. Not only is there no need, but it increases the operational complexity of running an already complicated system. Ignite is a distributed technology, and then adding a second one in just to be able to do full text search, unless it wasn't supported at all by Ignite, there's no real need to do it. So that's the main reason for not opting to use an existing technology. There's also the problem of not having the level of control that we do when we work with Lucene directly. And there are lots of additional considerations that we would have to take on board if we were to adopt external technologies for this. And that's the end of the presentation itself. What I'm going to do now is I will do a quick demo, and it will just show the model that we looked at earlier. So this model, where you have an item, you have attachment, and you have a comment. Now, one of the things I didn't cover in the slides is the ability for you to do scripts, and our serverless technology allows you to run Java or JavaScript, and you can choose about a dozen different locations at the moment, basically hooks. There are about a dozen different places that you can run a script as a hook. And in this one, all I've done is in the definition for a comment, I've chosen to execute this particular function at the pre-insert and pre-update hooks, which means it will execute just before the data gets written to Ignite. And that script I will show you is actually this one that's commented out here. All it does is it will take the data that's being stored, it will get the account of the user that's currently issuing the query, and it will add that query, add that account to the from field of the comment. So for the demo, I've run through this and created most of the data ahead of time. I'm actually running the self-hosted version rather than demoing from online. Now, the first query I'll show you is how complex the queries that you can write can become. The ones that were on the slide were relatively simple, and they were simply name and some value. But actually, you can write nested queries, and you can write queries that are effectively the same as running a left join query if you were to do an SQL query. So here, for example, we're issuing a query that will search the type realm, and realm is a built-in type that's provided by one of the core apps. And within realm, you have organizations. Within organizations, you have members, and the members field is an account object, and the account object has a password on it. Now, to query the password object, all you need to do is use dot notation to access subfields. So you say organizations.members.password equals some password. And in this query, what I've done is I've just done this to demonstrate how you could write a query for a login page that allowed you to log in using either your username or email in a single query. So in this query, we're saying find the account where the password is that UID that I have on screen, and the email of the account is admin@hippie.io, or the username of that account is admin. And the result is displayed on the right already. And GraphQL, as I mentioned earlier, allows you to choose what data comes back. So in this left-hand panel, I've decided that the structure that I would like to get back, or that the fields that I would like to get back from the server, are these fields that you can see in the selection. Now, any of them can be optionally included. The thing that I want to point out here, though, is this Hippie object. Now, in the model that I showed earlier, there was no Hippie field. That's one that Hippie injects automatically, and it does it for a number of reasons. Because in the result, you can choose to extract additional fields. So you can start looking at, for example, when the record was created, and you'll see that the created field. Oh, sorry. The created field on members starts being returned, and there are a number of fields that Hippie provides under that object. The full list is on screen, and I won't put all of them in, but the pagination token, the release, and I'll talk a bit about what that means in a second. But if, for example, you wanted to paginate, if your query was going to match a huge list and you wanted to paginate through them, when you query, you can get the pagination token. And by passing this back through as the from parameter in the ArcQL query, you can then paginate from that object. So the results that come back would start after the last one that produced this pagination token. Now, for our to-do item, I've already created an app with the model that I showed you earlier, and included the script when I created that app. So to create items, the functions I mentioned earlier, exactly as it was in the presentation, all you need to do is decide which object you're going to work with. And you can choose to work with any of the objects. If you decided, for example, that you wanted to work with comments directly, you could work with comments directly. And you can search for comments. You can also create comments directly, and after you've created objects that are done independently, you can actually then just reference them by ID. So if you created an object with some ID comment -2, for example, and then when you created a comment, you wanted when you created an item, you wanted to reference that comment, you could simply add that in to the data that you passed in, and specify the Hippie object with the ID, and that would effectively generate the relationship between the item that you're now creating and the comment that was created separately. I've got this structure wrong. So with GraphQL, your data must match the structure that you've defined in your model. So that error on screen is just telling me that I've got the field wrong, and it's because it should be plural. There you go. Now, the other thing is that you get validation automatically with GraphQL. So you'll see here that it's telling me, in order to create a comment, that the text field is missing. Now, you've already created this comment. If you wanted to add it, you would have to add it during an update of an existing item. And the reason for that is the type. So Hippie generates, or I should start by saying GraphQL distinguishes between output and input types, and Hippie generates the input types for you. So there is an item input type and an item input opt type. And the input opt, you'll see as soon as I change that type, the GraphQL error goes away. And the reason that goes away is because input opt, when you're doing a update, because you've already done a create, all the required fields would have had to be specified, otherwise the create would have failed. So the required fields are removed in the optional types that Hippie generates for you. And that's pretty much it. So this allows you to write your models. From your models gives you a CRUD API, and there is generally not a lot you need to do on the back end to get a basic CRUD app out. You can, as soon as you can write and define your model, you've pretty much got a working backend available for you to start with. The scripting functionality, like I said, you've got Java and JavaScript, and you can use those to extend the functionality that is automatically provided for you. I mentioned earlier that we are going to be providing a SaaS version of this, and we're at Collision Conf in Toronto later in May, I believe it is. Yeah, so from May 20th, and we'll be launching the SaaS version, so the hosted version of the platform at that event. And I went ahead and created a lot of this ahead of time, but what the SaaS version will allow you to do is to be able to, instead of working with the API as I showed you, it will give you a pretty UI on top of it, but it's actually just using the exact same model that we looked at earlier, so it will give you a fancy UI to edit all the things that we were just typing in and having to manually escape. The UI will do that for you. Yeah, and that's the end of the webinar. We have probably 2 events, one of them in London on the 11th of April, and then we have another one in Canada ahead of Collision Conf. So if you are interested, reach out. Nicole can send you information around those. And if you're interested in using the SaaS version of this, we'll be sending out invites once that goes live ahead of our hackathon on the 11th of April. And that's it. Thank you, everyone.
Thank you. I think we have some time to give you the opportunity to ask some questions to our experts. So if you'd like to type your questions in the Q&A panel now. I see that we've received some questions already. Is your platform open source?
Not just yet, but it will be. So we're planning to open source when we are at Collision Conf in May. So ahead of the event, when we run the hackathon in Canada, we'll be open sourcing everything then.
Thank you. The next question I have is, why did you not use the built-in Ignite persistence?
So Ignite's built-in persistent was custom made by the Apache Ignite team, and it's great. One of the things that we wanted to be able to do is reduce the storage. So when you work with the default persistence in Ignite, it allocates files ahead of time, and it allocates them to be of a certain size. And we found that for some of our customers, it was allocated, for example, I think it was 500 meg files ahead of time, and that became a pain point. So we swapped it out for something custom. So it was either we used something like RocksDB, or we modified how the Ignite persistent technology was implemented, and RocksDB was definitely the shorter route to production.
And that leads to the next question. How can I add my cache store or use the existing Ignite persistence?
So if you're running the self-hosted version, there's an XML file that you can use to customize Ignite, and that's the default Ignite.xml file. You can override the persistence technology that's used by providing your own implementation. It works using Java's service provider interface, so you specify the fully qualified path to some class that's available on the class path, and at runtime it will load that implementation and use it. So if you wanted to use, for example, the built-in Ignite one or one that you've built yourself, you can simply swap it out in the self-hosted version by just providing the path to the implementation.
Thank you, Courtney. We have time for a couple more questions. How do you specify node requirements?
Node requirements are done using environment variables or the configuration file at startup. So if you wanted to specify, for example, that the node had SSD available that you can then work against later, you would specify those either in the config or at runtime, again through environment variables. And when you're querying, you can specify them as part of, you use a directive. I didn't demonstrate that directive in the queries I showed, but you use a directive to specify the requirements at query time.
And finally, what if I wanted to write code in another language?
So as I mentioned, the two languages that we currently support are Java and JavaScript, but we're working on an integration with a serverless technology called Nucleo, and that will effectively allow you to be able to run what's, I guess, more traditional, even though it's relatively new, more traditional serverless functions. And you can, whatever, with Nucleo, pretty much anything that you can put into a Docker container can be used as a serverless function. And by just putting it in a Docker container, you can choose the technology, you can choose the language, and as long as you can run it in a Docker container, you'll be able to execute those. Now, one thing I will point out, though, is that when we execute the Java and JavaScript that is currently supported, that's all in the same process where Ignite and the rest of the Hippie platform is being executed. And what that means is that your data gets the benefit of having data locality. When we finish the integration with Nucleo, that will change because we will have to basically move the data out to Nucleo, have your serverless functions operate on it, and then collect the results and bring them back into Ignite. So that's the only slight downside, but we are working on a Nucleo integration, and then that will give you complete flexibility in how you can write serverless functions, and you won't even have to write it in any particular language. You could do a bash script, for example. Like I said, anything that you can put into a Docker container, you'll be able to execute with Nucleo and the integration that we're working on.
Thank you. That's everything, all we have time for today. So I'd like to thank our speaker today and thank each of you for joining us and your participation. Thank you and have a wonderful day.
Thank you, Nicole.
Bye-bye.
Bye.